solution on a free response problem that we worked through in class the other day. It gives us another chance to practice or review how to find areas between curves, how to find volumes when those areas are being revolved around an axis or a line. This problem says let f and g be the functions given by f of x equals 1 over e plus sine of pi x, and g of x is equal to e to the negative x. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graphs of f and g, and let S be the shaded region in the first quadrant enclosed by f and g. And the first thing that we're asked to do is find the area of R. And we know that we need to set up a integral over some interval, and we need to determine where this point of intersection is between the two functions in order to know the upper limit of integration. And we're going to use our calculator to do that. We don't really have much other option in this case based on the functions. So we're going to put these two functions into the y equals menu on the calculator. We're going to use our calculator's calculate utility. So that would be second calc to get into the calculate menu, and then calculate and intersect. And what we find out is that we have how do we want to say this? Let's say f of x equals g of x when x is equal to b, which is approximately 0.161. And actually the calculator is giving me x is equal to 0.16069. And I want to store that value as b. So I'm going to second quit out of the graphing screen, and then I'm going to push the variable button to bring up an x, and then I'm going to push the store button so that my screen gives me this little over arrow, and then I'm going to select alpha b and hit enter. And when I do that, I store that value as b. And while I'm in the middle of finding intersection points, I might as well check the other intersection over here. So I'm going to go back to calculate an intersection on the graph and put my cursor closer to that other intersection point and find out that f of x is equal to g of x also when x is equal to 1. So that's going to come in handy later when we're working with the region S in part B. So now that I know my lower limit of integration is 0 and my upper limit of integration is approximately 0.161, then I'm going to write my integral. Let's say area of R, so I'll do with a subscript, R is equal to the integral from 0 to b of, and then I have to look to see in this region R, the top function is actually g of x. The bottom function is f of x. So I need to make sure I'm doing this, writing the subtraction in this integrand in the right order. So I have g of x minus f of x dx is approximately equal to, and here's where I'm going to go back to my calculator, go to the math menu, option number 9 for the definite integral. This is assuming that we're using a TI-84, and of course there are a lot of other options out there. And I'm going to put down here on the screen, since I can't bring up a calculator for us to look at, this is what my screen looks like. It's going to say FNINT for finite or definite integral, and then I'm going to put in my g of x function first, so that's going to be e to the negative x, and then subtract I'm going to have 1 over e if you're used to using the e to the x button on the calculator, there isn't just a plain old e button over on the other side. It's the second function on the division button. Plus sine pi x. Close those parentheses, comma x, because I want to integrate with respect to x. I want to start at 0, and I want to go to b. So I'm comma alpha b, and close off those parentheses, hit enter. And I'm getting an error for not enough or too many parentheses that I'm going to check on for a second. Alright, fixed that, and we get 0.0496235, blah blah blah. I'm going to be leaving that off anyway. So I'm going to round to 3 decimal places. We can round or drop on the AP test. So I'm going to have 0.050 as my answer to part A. And it's interesting as we move on to part B now that I have a time limit on this video of 15 minutes, which works out well for working on a free response problem like this. And the next job that I have is to find the area of S, and so I'm going to just jump right into this one. Area of S is equal to the integral from b to 1 of f of x minus g of x dx, because now we've switched which function is on top over this interval, and so we need to be careful to switch the order we write f and g in the integrand. Otherwise we're writing an integral that would give us a negative value, and we know that we don't want a negative value for area. On the other hand, because I'm trying to save time at this point, when I'm using my calculator, I'm not going to switch the order. I'm going to bring up the same entry, and all I'm going to do is switch the limits of integration. So I'm going to have this one go from b to 1 instead of from 0 to b, and hit enter. And that actually is going to give me a negative area on the calculator, but that's because I didn't change the order of f and g on the calculator. But that's going to save me quite a bit of time from having to go in and type the whole thing over again, because it was a pretty lengthy integrand with lots of careful use of parentheses that I had to do the first time. So any little bit I can do to save myself trouble of writing it in again is good. So I'm going to change the value that my calculator gave me to a positive value for my answer and round it to 3 decimal places, and I have 0.422 as my answer for part B. So that was a lot quicker once I had established the intervals I was going to use for these regions and decided on my limits of integration. So on to part C. Find the volume of the solid generated when S is revolved around the line y equals 1. Y equals -1, sorry. So quickly, here's a visual of what I'm doing. Somewhere down here I have a line y equals -1. This is the shape I'm revolving. How do we want to do this? Kind of a shape like that, and I can see that I'm going to be making washers to approximate the volume of this shape. And I don't know whether that helps anybody, what I just drew on there, and it certainly doesn't help me be able to see the work that I already did. So I'm going to take that back off, but it was useful for me to quickly figure out whether I want to use shells or discs or washers in this case. And also I can look here to notice that my outer radius is going to be the difference between F and -1. My inner radius is going to be the difference between G and -1. So I'm going to go ahead and pull that stuff back off and get to work on part C before I run out of time here. So let's go ahead and write volume equals, I'm going to have my same limits of integration as I did for the area of S. I'm going to go from B to 1. And I'm going to have pi times my outer radius squared. And I'm going to subtract pi times my inner radius squared, taking the integral with respect to x. And I mentioned already, my outer radius is going to be the difference between f of x and -1. And I could write this as f of x plus 1 if I wanted to, but it's okay to put it like this. Makes me sure that I know what I'm doing here. And then I'm going to go and put all this stuff into the calculator as well. And since I'm at 13 minutes, I'm going to go ahead and do that quickly without writing it down, and we'll get an answer up here in just a second. Carefully entering those values into the calculator, I get something that I can either write as approximately 1.589 pi, or since I already have a decimal that I'm rounding, I may as well go ahead and say that this is approximately equal to 4.992 and just include the value of pi in my approximation. So there we have it. We've worked all the way through this problem, and since I've changed the values, you'll have to check for yourself to see whether I've done this correctly or not. And I think I have, though. So that should be helpful in working on problems like this in the future. You can use this as a reference and practice some more problems like it.